Before we begin, let me give you a quick context. What I built is a structured instruction system that guides how coding agent operates inside a real project. Instead of random prompting, it gives agent a consistent way to work across different frameworks and teams. The workflow stays stable even when the technology changes. This is the flow we follow today. First, understanding the problem with current AI coding, then the structured solution, and finally, the disciplined workflow behind it. By the end, you will clearly see how this approach is different. Introduction. As I previously mentioned, this framework is a collection of structured instruction system, and we will be seeing how it works in the next coming slides. What it is not. It is not an AI framework. It is not an automation tool. It is not an autonomous coding system where it can work randomly. What it is, I just wanted to repeatedly mention that it is a collection of structured instruction system that enforces discipline when using AI coding agents. Who should watch this? This video is useful for you if you already use AI for coding but want more control on it. You feel AI outputs become messy in real projects. You want structured, reviewable, production safe workflow. You work in a team and need a predictable agent behavior. If you are looking for instant automation without review, this is not for you. Problem statement. Today, most developers use AI by writing random prompts or interacting with them or using the tool inbuilt instruction structure. The result is often inconsistent structure, uncontrolled scope, no planning, weak testing, no review discipline. The output may be fast but unstable. What this framework fixes? This framework enforces plan first execution. Planning and code generation are separate. Phase isolation. Execute one small phase at a time. Human review. Hard stop after each phase of approval. Mandatory verification. Tests, lint, build checks are required. It forces agent to behave like disciplined collaborator, not like a random contributor. What it supports. These instructions follow tool agnostic design. It works with all seven major AI coding agents like Claude Code, GitHub Copilot, Cursor, Windsurf, Client, OpenAI Codex Client, ChatGPT. One installation command creates configuration files for all supported agents. Different team members can use different agents. The workflow stays the same. It supports 10 framework specific instruction set. Full stack like Rails. It also includes views, turbo, stimulus kind of instructions over there. Backend APIs, Rails APIs, Spring Boot, Django, Express.js, even the front end kind of structures like React, and even if you wanted to build some libraries like Ruby, Python, Node.js, Java. Each framework has its own structured instruction set. Let's get into the workflow. It follows a disciplined workflow. After installation, the workflow is always connect, plan, execute, verify, stop, review, and continue. Everything starts with a ticket. The agent fetches or reads the ticket, normalizes it into a structured format, creates a phased plan, waits for the approval, executes only one phase, runs verification, and then stops. This is no autocomplete. There is no scope creep. Human remains accountable. This is the folder structure that you will get when once you install agent instructions into your project. It has a kind of structure where where our application context will be gathered completely in one place. Now, the master instructions, infrastructure, workflow features, these are for agent to understand your context rather than every time exploring your application. And coming to the docs, docs is the place where agent is going to write or communicate to you their outputs or their plans or whatever they wanted to communicate with you. And tickets is the place if you really wanted to rely on MCP, you can rely on MCP. Or if you don't want to go with MCP, you can directly have a read-only API kind of API kind of token for your system, and you can enable that token from agent.configs.md. As you see, you have agent specific config files all whole or across the system. So if you observe, it supports Claude, which is a claude.md file. By default, Claude reads that instructions. Similarly, cursor rules, Copilot instructions, and so on. Let's get into the demo next, and let's make our hands a bit dirty. This is the step-by-step walkthrough what I'm going to do. First of all, I'll install the agent instructions. Let's install that first. So I'm going to get into my repo, and once you get into this repo, you will find installation kind of steps. You can go through the readme and understand what exactly it is doing. I have a sample Rails project which is a shopping cart API, which is a kind of backend for a regular shopping cart application. Now I'm going to install these instructions in this system. Now let's get into the structure first. If you observe, this is a regular project. This is a regular kind of Rails project with all the things over there. So if you observe, it has app controllers and regular stuff which a Rails project in general will have. Now I will install my instruction set. Now the instructions has been installed properly. If you observe, you got a new folder called agent which have all these file structure over here. So this is how you can install my repo into your project. Once installation is done, you can use any of the coding agent. Here you have my Copilot attached to my project. If you observe, there is a change happened to copilot instructions.md. Whether you can tag that copilot instruction.md in the context, or you can simply keep quiet and start writing the instructions, because generally GitHub Copilot understand these instructions. Now you just need to ask this agent to initialize my agent instructions. Now what happens next is a sequence of steps where your project will be initialized with a whole context across the system. It will try to fill up all these particular blanks which are present over here. It will try to articulate the architecture. It will try to understand the architecture of your project. It will try to see the features that are implemented in your project. It will try to understand the infrastructure of your project, like dependencies, what is the deployment structure that you are following, and everything. And it has a workflow which defines the phases that we are going to implement. If you get into the instructions, so there is something called initialization.md. Here you will see how our project will be initialized. Now our project is getting initialized. Once initialization has been done, you will observe different set of files has been updated in our system. These are the files which are newly created by agent. So if you get into the files, you will observe the difference what has been happened. It accumulated all the environment that that helps the context more clearly. That helps the agent to understand what it need to do, what it need to gather as a context. Now let's push this code. Yeah, of course, this is just a testing code, right? So I don't want to be too much serious about that. So I'll directly push this to main. Don't do that in your regular applications. Definitely you need to raise a PR and you need to make sure that everything you're pushing is right. But for now, for the instance, I'm considering uh, this demo liberty, and then I'm trying to push this code to main. Once this code has been added and pushed to the respective repository, you got the superpower of these agentic instructions. I'm trying to push this code to the main branch. Now, here if you clearly observe, you can also see our agent got these abilities. So when you ask these kind of instructions, agent will try to respond accordingly. So it won't try to, like, see you with with a blank face. It will definitely understand what these instructions are. Now let's get into the next step, creating or connect to a ticket. Here, this is what the interesting stage is. Our agentic instructions provide you a pipeline directly from any ticketing system like Zira or Linear or GitHub issues from anywhere. So either you can connect your agent with MCP to that particular system and fetch the details and try to work over that, or you can manually add the API token related to that particular ticketing system, which has a read-only access kind of access, and you can give that token in agent configs.empty file. Once you give that, or you attach your MCP to the agent, it will directly fetch from that particular ticketing tool. If you are not doing that, there is another way that you can do it. Today, for this demo, I'm just trying to create a new ticket. So for that, we need to create our ticket in tickets folder. So if I refresh now, you can see that I have a tickets folder inside my project directory. Now, I will try to create a new file in this particular uh, folder. So I'll say that TSCK-20, a random number, I would say. And then I'm writing these particular instructions in my ticket. Basically, this is a shopping cart of a type of application. Let's assume that there is no rating concept in this particular application, and I wanted to add that feature to this application. Now I just added those instructions in my ticket. I'm just committing these changes because this is just a demo. Now I'll use my Cloud A, and this is another tool that I'm using directly so that it would be easy for you everyone to understand. Now I'm tagging my shopping cart application. Next, I'll ask my Cloud A code to plan what's the ticket ID. The ticket ID is TICK20. Plan architecture for TICT20. Sorry for my typos. Yeah, but this is what I'm trying to tell to my agent. Now, when I give this instruction, it will go to the system and try to read the agent instructions that is present in the system and plan the architecture for the given ticket. It takes certain times, definitely, for this particular Cloud code to interact to the system and get the things done. But at the end of the day, trust me, the tokens will be minimized for sure. Now, if you observe, Cloud code went into our repository and tried to analyze the ticket that it found, tick 20, and then it went to our instructions kind of database patterns, everything that we had written for it, and it tried to analyze everything. It tried to verify the directory structure, and it went to the architecture plan, and everything, and tried to create a PR for our application. So at the end of the day, it almost read all the master instructions. This context router is interesting. So instead of this is where the path changes from regular reading kind of stuff. This context router helps us to route to the correct places. Rather than getting all the context, this context router, it tries to point it to the speech feature specific kind of stuff. So this is pretty interesting and intelligent. This can be improved in future for sure, but yeah, this is where the concept differs from a regular flow. So this context router routes our agent to the specific to gather specific context required for this particular ticket. Now once everything has been done, it creates a PR for us. It creates a branch for us. Now I'll create a PR and I'll review that branch. If you observe, this is what the ticket plan that has been created. Now I'll go to the plan and I'll review this plan. So for namesake, you might be having some questions. You can ask here directly to Cloud Code, stating that this is what my question. Or if you feel that this is wrong, you can edit it directly in the plan, stating that this is not what I want. This is the other thing which I want. Once you are done with everything, you can get into the conversations and resolve the conversations, and then you can merge the pull request. Once your pull request has been merged, you are ready to implement the ticket. Before getting into the implementation phase, I just wanted to let you know something over here. If you observe, the plan has been created phase wise. Phase 1 migration models and model specs. So it has created the phase 1, and then in phase 2 it writes serializers, controllers, routes and request specs, and then followed by the rest of things. So instead of doing everything in one single phase, it will convert our requirements into multiple phases, and then it will allow us to implement. Now I'll go to my Cloud Code and I'll go with a new session, and I'll ask my agent to implement TICK hyphen 20 as per the plan. Now when I ask this to the agent, it has already have the instructions related to what it need to do when I ask this kind of what this kind of uh, you know question. Now it will fetch the ticket uh, from the directory, and it will try to see whether the plan exists or not. Once the plan exists, it will read the plan, and then once it got the plan, it will try to implement as per the plan. Finally, Cloud Code has implemented our ticket. Let's get into the implementation process. If you observe, initially it went through the ticket plan that it has created earlier. After getting into the ticket plan, it went through all the implementation steps and everything, and it clearly read and reviewed the files closely. Once it has reviewed the files and everything is completely done, now the next step is it started phase wise implementation. In phase 1 it has implemented this, in phase 2 it has implemented this. Once everything is done, it pushed the code to branch, and now we can create a PR. Once we get into the PR, we can see the files which has been changed. And from here, the regular senior developers role. We need to review this code and make sure that the code is particularly correct. And we also need to ensure that as per our whole project knowledge, is this code valid or not? And we need to make sure that everything works fine. But because of the agent instructions that we had in our applications, 80 to 90% of the times it will try to give the correct code as per the standards we have in our applications. Just to revise, this is what we followed. We installed agentic instructions, followed by once the plan has been implemented, reviewed the architecture plan, create or connected a ticket, and then in the planning phase we try to run certain commands and make sure that we plan those things and review and approve the plan, And once that has been done, we executed the phases and then review and continue, and then final verification has been done. Let's get into the benefits and comparison by using these agentic instruction stuff in our projects. Without this framework, the agent might mix backend and front end changes in one go, skip tests or write minimal tests. It also try to get into unpredictable situations, and it also try to do something which is not beyond our project scope. Everything is out of, I mean, like, there is a lot of stuff that which might go out of scope, and we can't control them. With these instructions, definitely there will be a proper boundaries for our agents to work. If we get into the comparison table, without framework, it would be a ad hoc and implicit implementation. With framework, explicit and reviewable. Scope is unpredictable when you don't have any framework, but it is controlled and phased with any framework that has been incorporated into your system. Now, testing skipped or minimal, but here it is mandatory. Review points and only. After each phase, we'll review in this particular framework. Control agent decides, but here human decides what to go and what not to go. Accountability ambiguous, but with our framework, human is accountable for anything that's been happening in our system. So yeah, this should be a universal acceptable kind of discipline that we can grow in future. Repository information will be in comments. If you really wanted to help me, try to contribute as much as possible for the repository. That really helps me a lot. So open source contributions are always accepted, and try to get into the repository and have a look and try to help me to enhance this repository so that wide people can utilize these particular instructions, and definitely that will be helpful for many projects to get into a clear kind of workflow. Thank you very much for your patience. Have a great day.